When we think of a traditional production, it's impossible not to think of SDI. Serial Digital Interface, or SDI, is part of just about every production at every level. One of the great things about SDI is that it's evolved with the times, going from simple standard definition all the way up to 4K. But SDI isn't perfect. Everything from needing a separate reference signal, to short cable lengths, to needing an expensive router are all some of the issues we face every day with SDI. A switcher has to be able to use SDI, but also embrace new standards like SMPTE 2110 to take advantage of the latest technology has to offer. It's often said that ST 2110 is the future of high-end production. But where did it come from? Well, the same governing body that created SDI also created ST 2110, SMPTE, or the Society of Motion Picture and Television Engineers. So why do we need a new standard like SMPTE 2110? Well, SDI is great, but it couldn't do everything. ST 2110 was designed around the latest technology, enabling things like a single cable for both video and audio, along with reference, and the idea that a cable could be miles long, not just hundreds of feet in length, along with ideas like identifying the source of a signal and having a bidirectional concept, sending signals from one direction, for example, a camera to a switcher, and then from the switcher back to the camera again, and being able to use inexpensive routers, or commonly known as COTS products, that allowed us to take advantage of an ever-growing number of products at a much lower price point than conventional, very expensive SDI-based routers. One of the bigger issues with SDI is the fact there's no embedded reference. If you want to synchronize cameras, you need two signals over two cables. Video, for example, from a camera, and reference going back to the camera. ST 2110 solves that issue by having a single cable that can carry video from the source and reference back to that same piece of equipment. The way we synchronize sources in SMPTE 2110 is with PTP, or Precision Time Protocol. Unlike reference, which uses a beating drum, if you will, to keep everything synchronized, PTP has a clock to keep everything in time. One of the great benefits of PTP is that it allows signals from the switcher all the way up to the point of transmission to be kept in time or synchronized. When an SDI router is used, both sources and destinations are identified by their connection to the router. But in ST 2110, every source or stream has its own IP address and can be identified at any point in the entire production chain. Let's say you have 5 cameras connected to an SDI router. Technically speaking, the router doesn't know which camera is which, and so you might misroute the wrong camera to the wrong destination. One of the great benefits of ST 2110 is that every single source, in this case a camera, has its own stream ID. So no matter where it goes throughout your entire system, that stream ID is present and you always know if you've got the proper source routed or not. Taking advantage of this unique stream ID capability in ST 2110 is something called NMOS. NMOS is the ability for a controlling system to route signals from a source all the way through the system based on those stream IDs. Using NMOS, you've got the ability to change all the sources from your router to your switcher and know precisely what signals you've got going to each and every input. Because of its future-proof capabilities, ST 2110 should be considered for all big projects. Concepts like miles of cable length, resolution dependence, embedded PTP to synchronize your sources, and commercial off-the-shelf products in place of very expensive SDI routers are all great examples of why SMPTE 2110 is part of the future, and why Kairos natively works with SMPTE 2110 both in and out.